My name is Jonas Rosén, and as Per said, I work for a company called Eurostep, but I work as the chairman of TK280, and I will show some slides how that's organized later on. And I will first introduce myself a little bit here. I have my academic background. I have a master in computer-aided design and manufacturing, and that's where my my interest for working with information management and interoperability and exchange of data, of product data. And I found that being very interesting, so I pursued that, and I've been a researcher. I have a PhD degree in with an ambitious title, Digital Plants, how to build industrial information systems that are based on standards. So that is my academic background. And I think also I was doing a lot of work in my early years. Amongst them, I was working for a company called Prosolvia Systems that was a Swedish company doing simulation software and virtual reality and things like that. And I think, Per Gullander, you were also at Prosolvia Systems, I think, back in those days, more than 20 years ago. However, since 2000, I work for a company called Eurostep, and for you who knows some of the standards, you recognize the name STEP. And Eurostep was founded in 1994, working with building up the standardization organization called STEP inside ISO. Working a lot with starting up that, and also developing and helping the companies to develop their information models and standards. In those days, Eurostep was a consultancy company. I joined 2000 and started a software company within Eurostep, because we thought there was things to do with how to share and collaborate with product data across companies. So we decided to build a software around that. Today, I am a technical fellow working with a little bit of everything at Eurostep. When I started to work at Eurostep, I was the principal architect and for the product, which is called ShareSpace. Today, we have a software factory, so I'm not really part of that, but I'm the product owner of a product on top of a ShareSpace platform, which is called IA, it was released November 2021, just a few months ago. And it deals with AEC and plant information management. So I've been working a lot with implementing integrations between different types of information systems within companies such as Hägglunds, Saab Automobile, Volvo Aero, Siemens, Siemens Finspång, Ericsson, Volvo Trucks, Swedish defense, UK defense, US defense companies, working with Boeing, working with Airbus, working also with infrastructure in the National Road Administration in a project called ANDA, and some more. But since 2018, I think it is, I'm the chairman of this Technical Committee 280. And I will show you the next slide. I can show this is a organizational picture here, and shows in the top we have within the Swedish Standards Institute we have this Technical Committee 280, which is a mirror committee of an international standard technical committee within ISO, which is the name ISO Technical Committee 184. Within that ISO Technical Committee, there are 3 subcommittees, and this group, the Swedish TK280, is a mirror where we do work with these 3 subcommittees inside ISO. And what I will present hereafter is I will talk a little bit of standards from a high-level perspective, and I will also not only talk about standards within these technical committees. You know, as you know, there is a large number of standards and standards organizations that are there is a large number of organizations within ISO, but also within the IEC. And then there is also a lot of other standardization organizations that have their standards that in many cases sometimes overlaps. So I will just talk a little bit loosely about some examples of some standards that is relevant for when we talk about the digital twin and smart manufacturing and so on. Okay, let's see. Okay, so here we go. To start with, it's a little bit blurry, this picture, but I will not dig too much into this, but we will talk about the digital twin, and this is the target of a presentation, how standards can be used to support the use of a digital twin. There are many different definitions of what the digital twin is, and that's because there are many industry verticals that addresses the need of digitalized industry, and they have their information needs and set up their standards and way of working with it. And there has been a lot of work actually within, for example, ISO and IEC to collect and gather the definitions found in industry about the digital twin. Because as of today, within the standardizations organization, there is no formal definition of what the digital twin is. That is something that's a buzzword, so to say, if I should be a bit blunt. But still, if you look at a lot of the work going on targeting the digital twin and also the digital thread when it comes to smart industry, which, smart manufacturing is one part of a smart industry, one can say. There is a lot of standards used, and many of those standards are standards that have lived many years before the concept of a digital twin was being brought up in today's environment, so to say. So it's not, even if we talk a lot, we use the digital twin and digital thread and smart manufacturing and smart industry. A lot of us, even if these are kind of new concepts, the underlying standards that we talk about and things, they have been working with this information that is needed for the digital twin for many years before this. So there is of course, new standards evolving and new frameworks that talks about how to apply and use standards in the context of digital twin. Okay, let's see. And just to give you an overview of what I want to show here is that there are different application areas, and there are also different standard development organizations that works with digital twins. And as you can see, there is building, we have healthcare, we have energy, we have smart city, we have manufacturing, and we have farming. And there is, of course, lots of other application areas talking about the digital twins, and to that related different standards. So this is just to give an overview of all the work that is going on, and this is showing it from an ISO and IEC perspective. So you can imagine that there is a lot more, because there are a lot more other organizations than ISO and IEC that is working with this. And this is also a challenge, because as we can see, as I have highlighted here, we have different verticals. We have smart cities, smart manufacturing, etc. And if today, if we want to work in using digital twins and digital threads, and we would like to have a digitized information to work with to become smarter, we need to have structured information, not only if the information is digital. A lot of information today is digital. We are working with digital tools, but a lot of information is not, as we call it, structured. Structured means that when computer systems talk to each other, they need to have structured information so they know what to read and what to write, so that they are interoperable. They cannot find out things. They need to have explicit representations of information. That's why what we talk about having a structured digital information. If you have a PDF file, that's digital, but the content is something you need to open up a PDF file. You need to read it and understand it. There is a human process to gather the info, to gather the information and know what to do with it. But we need structured information for computer systems to interpret that data. And that is something we also talk about. There are many standards, but for a standard to be interoperable, we need to have standards, so we don't need to translate between different formats. And to be interoperable and exchange information between computer systems, we need to have machine readable standards. And those are the type of standards that I will try to address here. And these machine readable standards, in the picture I showed you before, SC4, the subcommittee 4, which has the STEP standards, and also has not only the STEP standards, they also have something called ISO 15926, which is the oil and gas industry standard. But the SC4, the STEP standard, that has been it has been around for quite some time, since the 1990s. First focusing on 2D drawings and 3D drawings, but it's much more than that. Those standards from the STEP community, those are machine readable standards, but they are using information from other standards that are not machine readable. So I will come back more on that later, I think. But here I just want to show that working with standards, if you are not used, everyone tells you that we need to have interoperability. And to have interoperability, we also need to have standards. So we know what language we talk when we talk to each other and how to understand it. And we have to have agreed definitions of concepts and things like that. But it's not easy because there is such a large amount of different standards. So which standards should you pick? If you are new to this. And this is also a problem for us, that we are working a lot with standards. I've been working with standards for over 30 years, and I'm still every day learning new things about, because we need to, standards evolve, and there are new standards in different communities that comes along, and you need to constantly learn about that. You cannot work only with one standard within one domain, so to say. But that's as I put it, that's a challenge. There are many good standards, but it's not easy to know which standards to use, and it's not easy to if you have picked the standard, there's a lot of effort to understand how to use the standard as well. But on the positive side, one message is also that instead of inventing new standards and not looking at standards, the standards that does exist, many, not all, but most and many of the standards that you found within ISO and IEC, it's high quality standards. There is a lot of work that has been spent on producing those standards, and there is a high quality requirement to be able to publish a standard. There are high requirements on the content. So if you are using standards, there is a lot of value inside these existing standards. So it's a challenge to know which standards to use, and it might be a challenge to actually learn and how to use the standard. But when you have started the process, there is incredible value inside the knowledge that is inside those standards. Okay, now I'm been preaching a little bit here. So I will jump into an example here. I have picked, you can see the source here, in 2020. This is one example where they have made a survey of different standards that might be applicable from a smart manufacturing perspective. I think this is a good example that shows there is a timeline also that you can see that there is an evolvement of standards as well. And you can see here between 2012 and 2016, you can see that there are a number of standards that the authors of this paper found relevant for smart manufacturing. And it's a good representation. This is also common findings that these standards here are some key candidates. If you are into smart manufacturing and look at it from a part perspective, this is a good overview of some of the standards that are relevant. But it also shows, as I said before, it's not one standard for smart manufacturing. And this is also, as I consider it, this is smart manufacturing. This is a rather small scope. It shows the from a design perspective, when you design products, from a smart manufacturing perspective, for example, they highlight these step standards. And as I said before, the STEP is a family of standards, and what you normally use in industry, if you are a automotive manufacturing company that designs parts, if you have a CAD system and a PLM system, in the CAD system you normally, for example, can export and import CAD geometry and properties and things that are not only geometry according to this step. AP214, AP203, that has been used until 2012. Those standards, the AP214 and AP203, those have been that has been a standard for exchanging CAD and CAD data between the high-end and low-end and medium-range CAD systems, and they are still supported. There is a lot of information that you can still use AP214 and AP203, but there is a new standard which is called AP242. As they say here, I think it was starting in 2014, and today, 2020, there is a standardized, this AP242 replaces the AP214 and 203. But AP242 replaced AP203 and 242 and 214 and contains all the geometry that those two standards could use. But it also has a lot more. It's supposed to support additive manufacturing and things like that, and it has some more representations of geometry than the AP214 and 203 had. And just a word on the AP214 and AP203. These have been considered, those have been quite important standards and quite big standards. If you look at the content of the AP214 and AP203, they are really large in terms of the information that they cover. But also in here they are depicted as two different standards, but they're actually overlapping each other, the AP214 and AP203. So there is a huge overlap there. They actually have the same geometry representations, but in the history, AP203 was developed and used by the aerospace industry. At the same time, the automotive industry developed AP214, and later on they realized they had such a huge overlap. So that was one of the reasons why the AP242 was being developed, because they wanted to align those standards. AP214 is a larger standard than AP203, but all the geometry all the things that was in the AP203 was contained in AP214. Yeah, but now I talked a lot about some of the details of, for example, how some of the big APs when it comes to within STEP when it comes to the design here. But we also have some other important standards to support us in smart manufacturing, because we need to represent tools and cutting tools. For example, the ISO 13399, that's a standard defining cutting tools. We also need to have there are also standards that address when you do planning for inspection. That's all of these activities are key activities, and you see that there is not one standard that covers all of these activities. There are different standards. So this shows, and each of these standards are high quality standards, standards that are used in industry and so on. So if you are new to standards, this is what you have to deal with, a collection of standards to support you in, for example, in this case, smart manufacturing. And then there is also overlap between the standards. For example, there is within metrology and inspection, there is this QIF, which is standards that today have been incorporated into the ISO 184 subcommittee 4. So those standards have been incorporated there and will become ISO standards as well, but they emerge from American industry. But for one example is they also have a lot about geometry definitions in there. So that's an example where we have geometry information in the KIF standard, we have geometry definitions that is within the STEP standards, which are overlapping but a bit different. Yeah, so this is the reason why I show you this is a typical example of different standards that you need to, that high quality standards, but there are different standards, and it is something you have to deal with, how to manage. You have to build up knowledge around the information needs that you have, and then see how different standards fits depending on where in the application you are here. But just also want to show you that it's quite easy to get stuck into a domain like this for smart manufacturing. But what I showed you here is only one aspect of a digital twin with a scope of a smart manufacturing here and process planning of parts production. But the digital twin is also something that we need to manage in a wider scope. We have an enterprise, we have enterprise resource management. We need to have the parts that have been designed and manufactured, the actual parts. We need to have a trace between the parts that have been delivered and that is in use, so to say, as well. So there is also a need to have this as the digital, to have a digital twin in the context of something which can be called the digital thread by some, which means that this also puts it into perspective. And there are standards for that as well, which I will go into next here. Yeah, this is a very high level example also, but now I move up from being into the digital twin inside the smart manufacturing scope. This is also from industry, that if we need to keep track of not only, we have a life cycle perspective of the parts that we design and produce and deliver and use, and not only parts that we produce, but the equipment in our factory, in our plants, the assets that we have, depending on in which industry vertical we are in. But this shows that there are many sources of information, and we want to have some kind of digital thread that can manage the links between the different pieces of information across the life cycle. So this is a typical example where if you have a plant, you not only have a part. If you are a manufacturing company of parts, you need to have information about from a plant perspective. You want to have the equipment of a plant, and those things can be complex products of their own. They can be exchanged and defined using, for example, step AP242. We have a building and the infrastructure of a plant. There is a standard called IFC, Industry Foundation Classes, which is popular in the building information management community. So in a plant, we have a building information and infrastructure, we have equipment, we have also, if from a process oil and gas perspective, we have PIN ID drawings, different schematics we want to have in. But we also have a lot of other types of information, for example, coming from ERP system, procurement system, maintenance management, planning systems, and things like that. So we do have a lot different types of information, and there are standards supporting that. But when we bring that information together, there is also a need to support this complete life cycle of a product. And there is a standard here which says PLCS. That's one of those standards that addresses the full life cycle of a product, but perhaps not all the details of a product. It can manage the details of a product, all the details of how to manufacture and do inspection on a part. That might be contained in other standards, like I showed you before. But we also need to have these type of life cycle management standards that supports the full logistics of a digital thread, so to say. And it also shows you there is a standard called ISO IEC 81346. That's not the machine readable standard. But it's a standard that is used by many verticals: the oil and gas, the energy sector, the automotive, there are many, the building industry. So that's kind of a standard. It's not the machine readable standard, but it has design principles how to structure your information. So that is one type of standard that works well in combination with the machine readable standards, for example, the PLCS standard. And then, of course, there is also an important standard called 15926, which is kind of covering a large information scope as well as the PLCS.
I am currently the co-chair of the joint working group between IEC and ISO that's looking at smart manufacturing. But this is only one of the many groups that are looking at smart manufacturing and trying to make some sense of what's going on. We are in a time of massive changes of capability in terms of what we are able to do, computing power, networking power, memory capabilities, the ability to make smarter and smarter devices, smarter and smarter machines, has basically meant that we are basically at a revolution right now in how we are looking at manufacturing and how efficient and productive we want to make it. I have been involved in several other committees as well, including development of the ISA95 committee, which is also the IEC standard. Been involved in the cybersecurity committees, batch committees, several others over time. And when the smart manufacturing started, I was able to jump in there to try and help. As co-chair, my job, I often say, is to herd the cats. It's not necessarily to provide the information, but there's a lot of smart people involved in trying to make smart manufacturing available around the world. And a lot of this work started in individual countries. So we take a look at, Germany has the RAMI models, China has models, Japan has models. Pretty much every industrialized country is working on smart manufacturing and looking at it, with the goal to make their country's manufacturing smart, which is make it much more competitive. So we've had a lot of questions that were going on as this, who's doing it? Why are they doing it? What is the value that people hope to have of? And how do we make sense of this? How do we look at these efforts and determine what is best for each individual problem? Because there were so many different standards out there, and there were so many different models that were being applied. It was very confusing. Probably still is extremely confusing about what is smart manufacturing. So, of course, obviously, the first question is, if there is smart manufacturing, does that mean that we have been doing dumb manufacturing before? And everybody who wants to admit that, please raise your hand. I never get anyone to say that. No, we have not been dumb before. We have not been doing dumb manufacturing. We've been very productive at manufacturing. We have been doing this since the Industrial Revolution. So for a couple hundred years, at a few percent productivity per year. The productivity we have today is basically incredible. For many products, all you need to do is have one manufacturing facility to meet all the needs of the entire world, though many companies will actually have 2 to 3 just because of supply chains and because of insurance to make sure that if something goes wrong one place, you don't have others. But we recognize the fact that even today, the most productive manufacturing probably has 20 to 30% improvements that they could make without significant changes. So throw into the fact that we already know that we're not as productive as we could, and we now have a lot more capabilities that are showing up with things like artificial intelligence, robotics, autonomous vehicles, the digital twin concept, machine learning, et cetera. And all of those things are really what is driving the smart manufacturing. We're really looking to say, how can we link a lot of the technologies to the problems that we have? And the problems we have today in manufacturing are not just the small problems, but the bigger problems of how do we get information from one system to another. I may be able to manufacture very well, but if I cannot tell my business system that I have finished, well, then it can't sell the products that I make, et cetera. How can I communicate the information from an engineering system into the production and manufacturing system, and then into the maintenance system? These are the things that we're really looking at for smart manufacturing, to say, how do we take a lot of these technologies and apply them into the manufacturing space? And everybody's doing this. So if you were to take a look at the list of these, and I'll show you some of the standards that have been developed or the models that have been developed out there, you'll see that China has one or more, Germany has some, Japan has some, France has some, Italy has some, England has some, Sweden has some, US has some. All of these companies or countries have been looking at the concept of smart manufacturing and saying, what does it mean for us? So in addition to the countries looking at it, there have been a lot of industry consortiums or groups looking at smart manufacturing, trying to say, okay, how can we, apply these technologies? The issue for someone looking at this on the outside is that you've got 40, 50 standards that deal with smart manufacturing. And how do you make any sense of these? How do you know whether or not that model really fits what you're trying to do? Now, most of these manufacturing standards are defining things called reference models. So it's important to understand a little bit about what a reference model is, so that we can see how this applies to what smart manufacturing is. So there's a lot of what we will call smart manufacturing reference models. And what a reference model does is it gives you a pattern of a set of elements and relationships in a very specific problem space, so that you don't have to reinvent the wheel, as we say, every time that you have a problem to look at. So, I mean, there's a reference architecture for bridges. You know, it says, okay, trusses or cables, stays or arches, so that when you're trying to define a bridge, you can look at the problem you're trying to solve. Is it crossing a big river? Is it crossing a small ravine? Is it crossing a creek? And then determine what pattern that you actually want to follow. Some of the other ones that are out there that are models are the aircraft carriers. This is one from Canada, Advanced Aircraft Design Lab, and they have a reference model for airplanes, looking at what your requirements are. You know, what sort of how many passengers do you want to carry, or how much cargo do you want to carry? How fast do you want to do it? You know, those sort of questions you have. And then that gives you a model to look at and simply say, okay, now I have restricted the problem space down to something smaller and I can start to address it. We have an enterprise architecture reference model. So if you are in the IT world and you're trying to define an enterprise architecture, how do all your IT systems work together? There are reference models there that talk about how you layer the different elements together. So a lot of these models here make the engineering tasks easier. And that's really what the reference models are. Now for IEC and ISO, what we looked at, our focus was manufacturing operations and the entire supply chain. The supply chain in this case being maybe within your company or alternately outside your company, and how do you communicate and get these pieces of it to work together? What's the model essentially that allows these pieces to work together? Well, we really did not want to start from scratch when we were doing this. So we started to look at all of the different country models that were out there. And that, I hate to say it, but that got us even more confused. And if you've ever seen a committee where people were confused, you recognize that there were a lot of loud voices and a lot of cat herding, as we say, to bring all these models together. So just a couple of the models that we look at. One of them was RAMI from Germany. It's a reference model for Industry 4.0. And the idea here was to say, okay, here are all of the elements and how do we represent these elements together? They have 3 dimensions of it that deal with it, the 3 different layers: the life cycle layer, the hierarchy layers, and then the kind of an asset to business inventory layer that's in there. It's a good model. It's a great model. And it's actually built on several other IEC standards. So they basically, if you say, I want to follow the RAMI, you'll be following the 62890 life cycle model. You'll be following the 62264 or 61512 models for the hierarchy levels. And then they have their own model for the layers that are in there. It's 3-dimensional. One of the things that we've discovered is that most of us who build those models, or most companies or countries that build models, they build 3-dimensional models because it's really easy to visualize 3 dimensions. What we've also found out was that 3 dimensions are not enough. That many people are trying to visualize 4, 5, 6-dimensional models. It gets very, very complicated. So you end up with multiple pictures. No single smart manufacturing model has just one picture. They always have multiple pictures that show how these pieces fit together. So the sorry about that. Another one that we were looking at was a model from China. It's the Intelligent Manufacturing Development Plan from China. Again, a three-dimensional model, system, hierarchy, equipment, unit, workshop, enterprise, similar to the 62264. The resources, resource elements, interconnections, and then the life cycle themselves. So a little bit similar to the RAMI model, but again, three-dimensional, the idea being, depending upon your problem space, you will focus on some aspect of those multiple dimensions. So we took a look at these, and then we took a look at multiple others, and I'll show you some of the other models that we looked at in JWG 21, trying to make some sense of this. I mean, how do you combine some of these models together? And in order, well, obviously the way that you want to combine these models together is to, because we're ISO and IEC, is you create a committee. Well, or in this case, you create multiple committees. There is a joint technical committee 1 that was working with the ISO and IEC, the sector management board and the technical management board, and they have several sub pieces underneath it. I call these the JTC ones more a coordination effort to try to make sense of it. Because if you look at ISO, you'll see that it's under TC 184 in ISO, there's several things, SC1, SC4, SC5, AHG, which is an ad hoc group, 1, AG1, joint working groups, etc. These are all working on things like data management exchange, artificial intelligence, digital twins, several digital twin efforts going on at the same time. And then there's also another coordinating committee, the SMCC. So there's a committee that between ISO and IEC, JTC1, but at the same time, there's also the Smart Manufacturing Coordinating Committee in ISO. There is in IEC an equivalent called the SM, the System Committee for Smart Manufacturing. And if you look at that, they have TC1, TC65, several different groups underneath there working, again, digital factory, digital twin, asset administration, Shell, multiple other standards. So JWG 21 was formed essentially to say, hey, this is like lots of things going on. Everyone is looking at their own individual problem space and small space. What we needed to do was to look at a bigger space to say, okay, how is this all play together? Now we have multiple models coming from multiple different organizations addressing multiple different problems. How do we make any sense of all of this? So that's what JWG 21 did. At the same time, IEC and ISO were working on a definition for smart manufacturing. And I'll be, okay, this is being recorded, so I'll have to be careful what I say here. But what we have is a definition of smart manufacturing that came from IEC and ISO, the SMCC, the Smart Manufacturing Coordination Committee. I think the key here says that manufacturing, it improves its performance, okay? With integrated is an important part of this, and intelligent use. Now, I hate to say, I would not think we want not intelligent use, but we have integrated use of resources, which include cyber and physical and human spheres. But in actual fact, what we're looking at many times is that the cyber is very much a big part of it. There's no reason you cannot have a smart manufacturing system and not necessarily have a lot of cyber in it. But I think most of the people looking at this said, the capabilities that we have in the computing systems and everything else meant that we can address problems that we can't really address manually. They're too complicated. When I have to solve issues of supply chains that may have hundreds of pieces, yes, there's probably a half dozen people in the world that may be able to address that, but computers can address this much, much easier. So what we're trying to do here is say, we want integrated cyber systems that improve the performance aspects of it. Okay, and those aspects include the agility, the safety, et cetera. So the key that we're looking at here is in addition to the manufacturing, smart manufacturing, is that smart manufacturing includes all these other elements. So it's not just the actual production itself, but it's also the engineering required, what it takes to build the factory, what it takes to design the products. It's the logistics, the supply chains. How do I get the pieces where they're supposed to be at the right time? It may include marketing, procurement, and sales. So there's several other aspects of this that show up in smart manufacturing. So this was the definition this is the definition of smart manufacturing. So now JWG21 said, okay, what is it we need to do here? How can we take a look at this and make some sense out of all of these different systems that are out there? And in order to do that, we had in JWG21, what's called the terms of reference, okay, which was the marching orders for this joint working group. Now, this joint working group has upwards of 100 members in it, but when we had physical meetings, we probably had about 20 people to 30 people involved in it. We have gone obviously to virtual meetings, but we still end up with about 30 people who will be attending these meetings on a regular basis. And then also we have people who are reviewing the documents that we generate without necessarily attending the meetings. So what we looked at was to say we had to prepare a unified reference model to support the ISO and IEC activities. Our charge was to create a single model and submodels that would actually work. What we ended up doing was not necessarily that, but what we ended up, because of the way these models are and how different they are, is to say we have a way to look at all of the smart manufacturing models, to categorize them, and for you to be able to define what parts of those models are important to you. And if you needed, create a very specific reference model for smart manufacturing for your problem space. So to do that, we did two deliverables. One, which is already out there, which is 63319. There will be a test on these numbers. Okay, so everybody try and remember those. It is a technical report, and basically what it did is it looked at the current status of all the smart manufacturing models and said, okay, how can we make some sense of all those models? And I'll show you some of the information that came out of that. That was released, and then we started work on 63339, which is the URMSM, Unified Reference Model for Smart Manufacturing. I had hoped it would be a shorter name, but unfortunately, we have a nice long, unpronounceable word here. This is currently in development, and it is basically says, when you're creating a smart manufacturing reference model, here is how you look at the problem space, and here's how you address it. So let me go over a little bit of the two deliverables and things that we had. The first deliverable was to look at all of the models that are out there. So we have China, France, Germany, Japan, Japan, US, Sweden, Korea, several different ISO standards, another Japanese standard, Canadian standard, et cetera. You can see that there's very little similarity between these, except that a couple of them tend to be three-dimensional, because that's the way that we think. It's very hard to think 4, 5, or 6 dimensions, even though you try to do that. So for example, the NIST model out here actually has like 5 dimensions inside it. There are others. We also looked at Spain, UK, and Italy, and some of the French models had like 8 different dimensions, but there was no way to physically represent that on a 2-dimensional page of paper. So looking at all these, the idea was, okay, how can we make some sense of this? So we pretty much spent a year and a half, 2 years over in developing a way to look at all these different models and to say, where's the similarity and where are the differences? So in the technical report, we list out the different models. We don't go into the details, but we do give you a reference so that you can go find those models. And then we said, okay, here's a way to look at this. Now, what I'm going to show you, I want you to recognize the fact that these are committees. Okay, so all names are compromises. Okay, so when we came up with this, we said, okay, how can we look at a smart manufacturing model that's out there, so we can start to make sense of that. And we came up with the terminology here of frameworks, facets, aspects, and dimensions. Dimensions are probably pretty clear. You can see that there are 3 dimensions. Facets are a collection of what we call aspects. Aspects are concepts, okay? And the concept may be something very similar, like I have a hierarchy of equipment. That's an aspect. A facet is a way to look at that. So you can think of this as a diamond's facet. You know, depending upon how you want to look at that diamond, you get a different view of information coming through those. So we have facets, a collection of aspects that can be represented in a dimension. The aspects are a collection of concepts for a particular context. So in a particular context, in the context of, let's say, an activity hierarchy, there's an aspect. In a context of a physical hierarchy, there's an aspect. In a concept of a life cycle, there would be an aspect. And then the dimensions are within that aspect, how these things kind of layer out. Now, the dimensions can be ordered. So if you look at the 62263, 61512, you have unit, enterprise, site, area, these sort of things. That's an ordered hierarchy. They can be randomly related. They can be time ordered. So if you look at a life cycle dimension, you're looking at time orders. If you're looking at business levels, they're not really ordered because they all communicate with each other. So these dimensions are in there. So we started with a definition of this and actually developed a very nice and complicated picture here of how you would take any of the models that we had, any of the models being developed, and said, okay, how can you represent this? And the goal of this being that we would actually create libraries of the different dimensions, of the different aspects and facets, so that if you found one that applied to your problem space, you would be able to pull that part of it out and apply it to your model that says, here's my reference model. Here's the solution space that I want to work in. We originally did this work on the TR, on the technical report, and it was an annex in there. The standard that we're working on, the unified reference model for smart manufacturing, actually takes this and explains it much more. You're seeing one slide here, but we're talking about 100 some pages to actually develop this. But the idea being basically that you have a smart manufacturing domain that says, what is this smart manufacturing model looking at? It's made up of facets and aspects and dimensions. Those are expressed in a different model here that says, okay, what are the views that we have of these? Now, this itself doesn't help you very much. You really need to look at how does this actually map into a real system. So we took like the Scandinavian smart manufacturing model and said, okay, here it is. It's a 3-dimensional model. And in that 3-dimensional model, we have various different pieces inside here of that model. And each of these lines here, each of these is a dimension, okay? That dimension is an aspect made up of aspects that make up the dimension. And again, the names were made up because that's what we do in standards, is we come up with words that mean stuff. So management, coordination, service interface, I'm not expecting anybody to read this at all. And then facets, which is how do you put these things together? How do you look at the collection of all the aspects inside a dimension to look at it? So essentially the team that was working on the JW21 and the report had gone through and said, okay, how do we map any of these models? Can we actually do that? And can we represent it? And again, the goal here is that you would be able to take a dimension and an aspect and a facet and say, okay, this one applies to me but maybe this one here does not along a different axis. But I want to use that model and then combine somebody else's model together, because that is the problem space that I am trying to address. Now, so this was the Scandinavian model. There's, again, text that talks about it, but it was an example. The RAMI model, you take a look at it at the same time. They have a dimension: business, functional, information, communication, integration, asset, et cetera. That's a dimension. The business, the functional, the information are aspects. And then the facet is the view that brings all those pieces together. So in this case, you've got 3 dimensions: life cycles, hierarchies, and layers. Okay. And they're made up of individual pieces. So for your model, you may not care about some of those dimensions. You may care only about parts of them. But the idea here is that we will eventually be able to represent these things here electronically. We'll be able to create a library of the different aspects, dimensions, and facets, so that you can go in there and say, okay, for my problem space, this one applies and this one applies, and let me bring those two together so I can represent that. We're not doing this graphically. As I said, it's 3-dimensional models here, because that's really the best that we can do. You see a lot of other things that show up in here, colors and others, to try and create more and more dimensions for us to start to look at. So the the Unified Reference Model says, okay, here's the definition. If you're going to look at this, don't forget the user aspects. Don't forget the user interface. Don't forget the context structure. Don't forget the content input that you have for it. So the coloring actually on this reference here helps a lot to identify the pieces that you need to put together. And the reason we did this quite early on was we recognized that no single model really suited all problem spaces out there. We had people in batch, we had people in continuous, we had people in discrete manufacturing. We had people who were working on electrical distribution systems. We had people working on power systems, on water systems, on wastewater systems. Anything you can think of, there were all these different problems, and they all wanted to be smart. So, but no single model really addressed that. And I think we have seen that. Many of these models come from people who work in one industry, and that is their primary focus. So as you try to apply that across other industries, it doesn't always work. Just like no single bridge model addresses all possible bridges. So, but there's a lot of overlap. There was a lot of conflicting terminology across it. We're hoping that the URMSM provides that common terminology so that we can compare and select the best models, and give you the capability of doing this in more than just the 2 or 3 dimensions. So here's a 5-dimensional hypercube. I'm sure that this would eventually show up in somebody's standard, but it becomes very hard for us as people to visualize more than the 3 dimensions easily. Here's some of them. So the Smart Manufacturing Reference Model, has business, manufacturing, and product. RAMI has layers, hierarchical layers, life cycle, and value stream. ISMA has life cycle, very similar. A system hierarchy, similar to this. Intelligent functions, which might be the same as layers, it might be the same as business, but again, a 3-dimensional. IVRA, and don't ask me to remember what all these names are. I don't really know. We start, they are very confusing at times. Okay, and it's made up of a 3-dimensional model with sub-dimensions underneath each of those, different views for activities, management views, etc. So lots of possible frameworks, lots of different ways to look at these, but what we're trying to do is make some sense of it. And what we're trying to do is hopefully take each of the models that exist out there in terms of the country specific and consortium specific and say, okay, here's the dimension, here are the aspects of the dimension, here are the layers. Now take these pieces together. Now talk about how they intersect. Talk about how the pieces intersect together, and then what you have to communicate to make those pieces work together. So how does my business level work with my life cycle, for example? Or how does my infrastructure work with the life cycle? Or how does my infrastructure work with my system hierarchy? You know, what does that mean when it goes all the way down to a unit or a smart device that's out there? Those are the things that we're trying to do, is to show that there are these dimensions, there are intersections. You apply the standards at the intersections so that these pieces can work together. Okay. So the URMSM will provide a common library of aspects. And we're going to put in a compilation of aspects from all the models that I showed you there. The German, the French, the Italian, the Swedish, the Japanese, the Chinese, the UK, the US, etc. A common library of dimensions so that you can reuse information from existing models. A way to describe this. And when we say common library, remember, we're talking about machine readable, not just a document itself, but a way to share those and create your own system. And because you want a common way to electronically represent this information. That's our goal. We're currently working on a draft of the standard. We have a committee draft, which is a CD that is out there. And we have been working on that over the past 2 years, virtually, obviously. We haven't had a face-to-face meeting since 2019, but we are progressing on that. The first part of this will actually define the way to represent the models. I'm hoping the second part of this standard will provide the electronic representation, some sort of XML or JavaScript representation of this information so that you can bring it in and then you can have some tools that allow you to display that. So a little bit of a summary here is where we are. You know, smart manufacturing is here. Everybody is addressing it. It is something that's going on around the world. There's many different standards that are in development, many different concepts that people are looking at. We are in basically a churn era time as people are coming up with ideas and new ideas in different ways, and everyone is trying to learn from everybody else. That makes it sometimes hard to understand what people are doing. So what we want is hopefully a way for us to look at a model and say, oh, these are your aspects, these are your dimensions, and these are your layers, these are your facets. The reference models that are being developed, they define an architecture for an implementation. So you basically say, I start with a reference model, I develop an architecture, and then I develop an implementation. So there's kind of a life cycle of those. We're at that first stage. What's the reference model that gives you the kinds of architectures you want to build? And then from the architecture, it tells you the kinds of systems that you can build from. It'll provide the pattern of elements and their relationships. It will recognize the fact that no single model suits all of the problems on there. And we're hoping that this will be a basis for the industry and problem-focused smart manufacturing models that are out there. So we're still early in the phase. Many times in developing standards, it's a multi-year process, particularly when you're looking at something that's supposed to apply around the world. And particularly when you have so many experts and so many people who know what's going on, that everyone needs to have their say in it. And it just takes a long time to get all these people together. But we're hoping, and we're pretty been successful so far at getting this reference model defined. If you're interested in it, you can go through your national committees. The committee draft is out for comment, or we have a new one that'll be coming out. We actually have a meeting coming here in a couple weeks where we're going to go over some of the comments that were received. We hope to have a committee draft for vote, which is the next stage of the standards, out by the next couple months. And then it'll go out for a vote. And typically those votes take anywhere from 4 to 6 months for everybody to get their comments in and get the votes in, and then get comments on us to start to resolve it. But our goal here is that in 2023 to have the URMSM IEC 63339 released. If you're interested in it, again, talk to your national committee. You should be able to get a copy of this. I do admit it's a standard. It's not an easy thing to read, but comments are definitely appreciated.
I would like to take a few minutes and to speak about this booklet that now is available. And it's a booklet that is called Technology is Silver, Standard is Gold. And we say that it's a booklet, so it's not a book. It's not that thick and it's not that heavy to read. And it's not a report, because this one is much easier to read than a traditional technical report. So we say that this is a booklet, and skrift. And it is available in Swedish as it is now, but it will also be available in English in let's say, couple of weeks. And the English title will be Standards of Gold. And this booklet that I have here with me, it's aimed for business leaders working in industry and that are interested in smart manufacturing, or curious about smart manufacturing, or a little bit afraid of smart manufacturing, or have questions about smart manufacturing. The purpose of the booklet is to describe the value-adding role of standards, looking at the history and as of today, but also looking into the future and trying to predict why standards will be important also in the future, especially now, I would say, when our industry is being digitalized. So are standards important? In this booklet, it speaks a little bit about that. And this, what I show here on the right side, is a questionnaire that ARC, a marketing consultancy company, were doing. And they were asking companies if they believe that standards will be important in the future. And as you see, 33% they say, yes, they will be important. And 63% they say it will be extremely important. And looking into this a little bit more, it also turns out that standards are especially important in times of technology shifts, because then standards provide both terminology and definitions. And it also provides a platform on which new innovations and new products can be leveraged, so that we will have many new products that can all interoperate with each other. So especially now in this time of changes, it will be important. The booklet also speaks a little bit about the technology shift that we are in the middle of right now. And as it says, it's not the first time that this shifts take place. It has happened before. The German way of presenting it is to say that this is the fourth time that it is happening. Therefore, the name Industry 4 can also be seen as the third time, depending on what you see as the drivers, as this figure here on the right. But independently of that, at each occasion, this shift has been followed by an economical growth and thereby also an increase in living standard. And that is why it's so important right now to be part of this technology shift. You would like to see this increase in living standard. So in the report, it speaks about the importance of standards then from the past, and especially now in this time of transition. And it also gives some information about how standards are being developed. Not all the tricky details and the bits and pieces, but to a more general outline. How is the process going? What is required? And just like Dennis said before, and also Ann-Sophie pointed out, is that you can be involved in different ways. And if you would like to really change what is in, or impact what is in the standard, you can become an international expert. And Sweden have some experts that are participating. For example, Ulf, that is part here, and Gunilla, that is part here. Both of you have been involved in this JWG21, the group that Dennis is leading and that we just heard of. So we really have Swedish experts in these groups. And there are many benefits of being involved. if it's benefits because then we, and now when I say we, I mean Sweden, we will learn from other countries. So by having Swedish experts, we can learn from what they are doing in other countries and how they are seeing a problem or how they are tackling this. And we can also let other countries learn from us, what we are doing and where we are front runners, and tell others about this. And then, as we discussed before, it's a compromise, and how do you continue and what do you put in the standard? But there is a lot of learning. But of course, to participate here, if there were no drawback, then everyone would participate. So of course, there, if you would like to participate, you also need to have some resources. And resources often means time, engagement, and money. And what we saw was that when we worked with this was that there is a lot of good initiatives in Sweden, a lot of things that we have learned, a lot of top technological and top modeling experiences that we could bring into the standards. But if you don't have the money, like small companies or lack of time and so on, it's difficult to do that. So therefore, there was a project supported by Vinnova, which is the Swedish innovation agency. And this project, the name of that was Strategies and Standards for Smart Swedish Industry. And the purpose of that was to provide a link between all of, on one side, all of this national ongoing development work that is bubbling in Sweden and that has a focus on smart manufacturing. So that on one side, and on the other side, the international ongoing standardization development work with a focus on smart manufacturing. So super important to have new standards in these times of technological shifts on one side, and there are a lot of very good work done in Sweden. So could we provide a link so that we can learn from others, but also learn how we are doing and how we are seeing things. So this 4S project that started, the intention of that was to find this national ongoing development work and provide this link, and also provide some resources. And resources in this case meant financial support. Financial support so that people could attend more meetings and present the work that we are doing here, and listening in to what others are doing. And the belief was that by doing this, Sweden will be seen as a front runner in smart manufacturing, and that of course is important. Behind this project, there were many organizations involved. Among others, as I said, it was supported by Vinnova, the Swedish innovation agency, but also PIA and Production 2030, which are innovation programs that you can apply if you would like to make a development work. Blue Institute was also very much involved, and it's also very much behind this booklet that I'm speaking about, and Lund University, where I am, and also SIS and SEK, the Swedish mirror committees. So there was a big group involved. And in the booklet, we highlight a few of these national ongoing projects, and we also highlight in what way they have been taking part of ongoing international standardization work. And you see some of the projects listed here on the left on the screen. So National Testbed for Smart Production, Digitala Stambanan, I don't know how to say that in English, sorry. Internet of DevOps, Lifecycle Data Management, which is now also a networking organization, etc., etc. So those projects that got some support from 4S, they are also mentioned here in this booklet, each of them by one page. And then in the booklet, there is also some reflection and looking forward. And in that chapter, it talks about the digital transformation and its corresponding market value. It speaks about some technological trends like concept we heard here, reference model, digital twins, clouds, industrial data, etc., etc. And in association with that, also the role of standards. So looking at the outline of the booklet, Chapter 1 here speaks about the value of standardization. Chapter 2 speaks about the digital shift in industry, also incorporating discussions about climate neutrality, sustainability, resource efficiency, and so on. And then chapter number 3 is the description of these projects that got support from 4S. And the last chapter is a reflection of the future development concerning digitalization and standards. So that is the outline of the standard. And this booklet, it's published by the 4S project that I spoke about, and Blue Institute, that is the main editor and the main author of the booklet. But as I said before, the booklet describes the value-adding role of standards in the past, today, present, and also in the future. And if you are interested in the booklet, you could either download a digital copy. You see the link here, it's a little bit long, but someone can put it in the chat, or I can put it in the chat later. Or if you'd like to have a printed version, if you'd like to have this one, to be able to read it from paper, then you could just send me an email and I will put it in an envelope and send it to you. And as of today, we have it in Swedish. If you're interested in the English version, that will be available in a couple of weeks. It's now under being translated. You can also write a note on that, and I will send it as soon as we have it.
I am the leading this forum, which started a year ago, as you said, funded by Vinnova, and we have Automation Region as organizing the workshops that we have had, and we have kind of standards expert from Lund University and KTH, and also CIS in this project. So the idea that we have is really that the company needs to be guided in this work. As we have mentioned, as you mentioned also, Charlotta, trying to work with product development, production development, and production, and in more digitized way, talking about Industry 4.0. There are issues both at the manufacturing companies and the solution providers like software developers or physical equipment providers and consultant companies. And there's a lot of issues here, and solutions, we say, are in standards. There's a lot of knowledge embedded in the standards and ready to use solutions in the standards. But there are so many standards. We have mentioned that earlier today. And there are also so many different standardization development organizations and other alliances. We have the ISO and ITU, IEC, but also many other organizations. Many different types of standards. And how should then the companies address this? How should they know what is available, know what to use? And also the other way, how should their companies' needs be really put forward to this standardization work in a better way, and so that that could impact the standardization work? And in this, we see that there is a gap, and the forum could fill this gap, at least part of the gap. So that's the idea behind this forum, that we could help bridge this gap, providing information and support. And the idea is that the Swedish industry then could be better at using digitalization and standards to really build production and developing production and product development in a better way using digitalization. So bringing experts and manufacturers and suppliers together in this forum, that's the basic idea. And also in some way kind of provide a guide for how to really understand what standards are available and how to approach this as a first and second and third step towards working with standardization. And we have funding from the Vinnova, the national funding agency, for this first year, which is a little bit more than a year now. We will have like a year and a half in the end. And I guess almost all of the people involved in this first year's work is available in this meeting right now. We have heard most of us talk. So what we have done, if you look in the mirror, we see that we have made like 4 workshops and 5, including this one, which have had a slightly different kind of angle. The first was more on the overview of standardization and challenges. We had a workshop discussing the industrial needs. We had a workshop talking about the industrial challenges again, and the opportunities that we see that standardization have. We saw that there was a need for providing kind of good examples of using standardization and industrial use cases being presented. So that's what we have done in the workshop way, and we also during the year trying to really understand the needs the industry have and trying to kind of form the offering to that this a forum like this could have to industry. We also then would like to develop some kind of simple guide, simple method to support industry in starting working. So that's the idea for the remaining part of the projects. And then the idea is that the funding from Vinnova has ended, that this forum will continue based on membership fees. So that's the idea. What is the offering that we could provide that is of interest to the Swedish industry? So interesting that they would like to pay for it. Nu hamnar den texten rakt över. So we have had quite a lot of different presentations over the year. Overview, specific standards presentations from academia and industry, research projects, use cases and experiences from industry, national and international standardization experts. We have presentations from SEIA, which is more of a kind of similar idea as our forum, with SEIA being focused on one type of industry and one type of standard and use of that. So we have had 5 workshops and reached quite a lot of, this is not the exact numbers now, but like more than 160 organizations and 212 unique participants. That's quite good, I think. So this is the good results of the first year, and that we would like to continue. We have this website developed, which is quite simple. You could perhaps someone could put that in the chat also, but you could go to our homepage, ri.se, and search for forum standardization, and you can find it also. Here we have all the workshops that we have had recorded by Automation Region available, and the idea is that well, you could press for interest and membership if you are at least interested in participating in this, and then we will come back to you. In the future, we would like to have some kind of login also for more information. We have had in the workshop we had on the 17th of November, we had a very simple survey asking a few questions. So one question was about the content of a forum like this. the activities, what is the content that you would like to find interesting. And well, this is a very quick survey, so we can't make too much of a conclusion from this, but it's very clear, at least from that one, that networking and exchanging experience with the parties within a forum, learning about industry examples and the use of standards in industry is most interesting, and also getting information about ongoing standardization and overview of standards. So this is the most interest shown for a forum like this. So I guess that's the main focus for the first start of this forum, would be providing this. And also we asked kind of the forum, how should we present that this content of network exchange and industry examples? And perhaps because of the pandemic and everybody's very used to being working from home, but most said they would like to have kind of webinars, online seminars, like 1 or 2 hour long. Workshops, yes, but online. And some kind of online networking meetings. We call that the coffee time, but sometimes very informal meeting to really change of ideas and experiences. So that's the picture that we got. So that is very much of an online activity that was appreciated. But I guess if we do this once again in a year, maybe we get another response. People would like to have physical workshops, physical conferences, perhaps. Also, I could present the kind of overview. We had this workshop last year in one of the workshops. We had discussion in one of the workshops to really ask of the industrial needs. And it's very similar to what we have heard before, but the areas that we have addressed in this forum and the meetings are quite broad. It's from the product development down to the production development and the digitized production. So it's a very wide scope in that sense. The problems that was raised that the industry face, perhaps not surprising, interoperability, coming away from the file-based data transfer, data formats that are not completely but almost compatible. That's one challenge. And connecting different systems like IoT machines and other to one interoperable solution. Connecting different, like the production with the product and vice versa. That was also one thing that was raised in the workshop. Change management, traceability, lock-ins problems to suppliers. That was a problem that was raised. Terminology, as we have heard, is the kind of basic idea of standardization. Cybersecurity was also raised. Another type of industrial needs that was raised was that in the standardization work, there are too few companies that are engaged in this. Especially, there was raised questions for getting more manufacturing companies involved, more software companies, getting in smaller companies also involved in this. And this is, of course, a challenge that the forum could address. It's easy to get the enthusiast on board and starting to work, but what's the next step? Going from the enthusiast and helping him to get more people at the company committed and seeing the benefit of standardization. And part of that could be a management anchoring. this is also needs problems that was raised, which we have also heard earlier, that there's a limited knowledge of standards in industry. Why should you standardize? What's the benefits? How does that benefit kind of balance with the costs? How should you start working? How should you apply the standards? How should you choose which standards to apply? If you want to get involved in standardization work, how should you get involved? And one interesting issue is this fright that kind of, if you standardize, you reduce the possibility to innovate. That's something that we need to address. Also, that standardization is not really working because we have very specific needs and the standards is not addressing our specific issues. So that's the needs and the forms and the contents of the form that we have seen. And so going forward, we have kind of preliminary view, which we would like to refine further in the next couple of months. But as we see it, there need to be one organization, and RISE will then lead and administrate the forum and the site. But we will need definitely a core group like that we have had this first year, CIS, Lund, KTH, Automation Region. Perhaps we should discuss if we have need for more people in this core group. That we form this group, and this work in this group is then funded through the membership fees. And idea for the activities would then be to continue the work with the forum website, where we could in the public website, then we could really present information about the forum, but also some other information that we find interesting or activities that are related. And step by step, we could then add more information on this website. And eventually also have some kind of possibility for members to log in to get more member information. So that's the website. And then we see that we could have kind of network meetings, perhaps once a month, mostly digital, and that could be only for members. Does not need to be very formal, perhaps some kind of presentations, but then open discussions. There you can share information, experiences, tips, ideas. We could ask each other questions and get information about ongoing standardization, for example, in these meetings. And then for also have workshop seminars, and at least in the beginning online, where we could share have more time for sharing of experiences, good examples, demonstrations. We could have, like we have had this year, expert presentation, information about specific standards, overview, industry examples, case studies, etc. So more or less that we have had this year. And I guess for all of this, also for the physical conference that we then hope that we could arrange, the number of workshops and the number of meetings depends very much on the number of members that we get. So the idea is then that we could have a fee depending on the size of the company. We will need to come back on how the level of that fee, I guess. I think the membership should be per organization and not per person. As the funding from Vinnova disappears, so that disappears in June, if we prolong the project now. And the idea is that members then do not have to pay for the online workshops, do not have to pay for the network meetings. They pay only for the membership once a year. non-members will then need to pay for network meetings and workshops and conferences. Members could have a reduced price for physical conferences like that. So that's a basic idea for this forum to take place. And the idea is that we could send out a survey after this, like in February, March, to all the participants that have taken part in these workshops last year, and perhaps broader than that, but to really get an understanding of. Then we could present a very specific idea for the forum and get the feedback to get an idea of if there's a working business model for this. And we hope that we could have a really physical meeting in May. The plan is to have it on the May 3rd. I guess we send out more information about that. Another international expert presentation, and we could present more about the forum as we have concluded. And also you could present perhaps more, Charlotta, about this report and the work behind that. We need to market, and then in July 1st, we need to start then the true forum work funded by the membership. And hopefully the group behind the forum could also then, we will apply for additional funding to be able to work more in the behind for developing this kind of guiding support and to run demo projects, etc. So that's the idea behind the forum, and that's what we have seen for this first year. And I hope that you will all join this forum, at least take contact with us, and so that we could give you more information if you're interested.